Pause. All right. I think I've got everything. Everything. I see Mark and YouTube. Let me turn my camera on. Hello, everyone. Hopefully you can hear me. Can you all hear me? Got Restream going. I think YouTube's live. Excellent connection. All right. Mark, you can hear me. Audio's okay. Thank you. Thank you. Thank you both. Is Twitch okay? I haven't seen anybody drop a note in the Twitch chat. If you're on Twitch, Mixer, or LinkedIn, or Periscope, drop a comment. Let us know you're watching. Should be okay. How do I make the live chat go away? I don't want to see the live chat there. Silly. Or I guess if I... and close this. Sounded better closer to the mic. Okay. I'll try to be better about being close. I'm also like muttering under my breath. Nickel, thanks for the feedback. Yeah, Discord doesn't like to be super small. All right, and let's check here. Nothing you shouldn't see. Can you see the top bar of OBS at the bottom of the screen there? I don't think so. The other thing I could adjust is the brightness staring me in the face. We'll get going in just a couple minutes here. I like to wait just a bit while we confirm everything's working. I can move this. It's going to end up blocking me a little bit, but I can try to be closer. And the overhead should be working today. Ooh. Because we're going to be doing some debugging. Thanks, Nickel. I appreciate the help. Oh, Mark says, I've been playing with Tio. It's nice. Now I just need to find a better way for it to name the serial devices in Mac OS. By the way, Tio is equal to is 10 in Swedish. Yeah, that's a great reminder. We should actually use that. I think it's in this tab that I've been using screen. Like I have this screen. I wonder if I can just do... Oh, this won't work now because it's not connected. Although I could turn it on. All right, one more minute and then we'll get going. There we go. It must not send the thing that says connected. Yeah, that's default baud rate. Oh, did we crash it? It might have crashed. Right. Okay, let's get going. Otherwise, I'm going to get into things. Because it's not working. I'm going to toggle it off just in case we are crashed. And I've got like more USB things going on than I normally do. So I want to be pretty nice to it, hopefully, today. Okay. Thanks for jumping in. Let me kind of here with this. Hi, everyone. My name is Scott, and I work for Adafruit on CircuitPython. I'm the leads developer and product person for CircuitPython, I guess. Every week I do these deep dives where I spend about 2 hours, at least 2 hours, working on some piece of CircuitPython that I've been working on throughout the week. This series is the goal is to chronicle my progression with adding support for the ESP32S2 to CircuitPython and show different techniques and things that are involved in getting that done. Housekeeping, like I said, I'm paid by Adafruit, so please go to adafruit.com and purchase stuff from them. If it's not available or in stock from adafruit.com, you can check out DigiKey. They carry a lot of our stuff. They ship fast, and of course, Adafruit makes money off that as well. I should say sorry for the noise, but the window's open because it is quite warm in here. So as FedEx things drive by, it might get a little loud. And then the other thing is, as some of you know, the cat who loves to lay in the window here, Spook is his name. He is epileptic, so there's a chance that he would have a seizure. You might hear like a cat hiss, and then I'll mute and I'll just watch him for about the 5 minutes. No, not usually longer than that, where he's seizing, just to make sure that he's okay. Then I'll hop back in, so you can go grab some water. I've got water with ice in it today because, like I said, it's warm. So just be aware that might happen. It has happened on the stream, so just a heads up. Couple shout outs. Hello to Unexpected Maker and Jared Salazar in the YouTube chat. Thanks for hopping in. Good to see you all. And the plan for today is I'm going to recap the work that I did on the ESP32S2 since last stream on Thursday. And then after that, we'll basically pick up where I am, which is debugging I2C, trying to get that working. So I've got a sensor. I've got the overhead going here. So we'll talk about this setup a bit more later. But I also have the Salii, so we can do some debugging. So stay tuned for that. Let me switch back to the camera. So that's the plan. Let's talk. Is there any other housekeeping I forgot? And I do like to do this interactively. So if you have questions about things as I talk about them, please pop them in the chat. There is a little bit of a delay, but just pop them in there and I'll answer them. I love to deep dive, as the title goes. So if you have questions, let me know. First and foremost, let's talk about where we left off last Thursday. So in the US, it was a holiday weekend last weekend, so I took 4 days. It was a 4-day weekend. I took Friday and I took Monday off. So I should have not got as much done, but it kind of feels like I got just as much done as I would have otherwise, which is good. Where we left off was we were trying to do the initial scan, I believe, and we were having issues doing the initialization. And I've since figured that out. And the problem with that was that we're relying on CMake, the CMake and the IDF stuff to build the libraries, the IDF libraries, and then we're linking to those, which means that if we have settings that are different for the compilers, bad may happen. And what it turned out is that there's a feature for GCC called short enums, which allows GCC, if it's on, to dynamically pick how long the values for a particular enum are, depending on how many entries there are in the enum, or what the values of the enum are. And the IDF has that off, and in CircuitPython we have it on by default. So that was causing some weirdness where, one piece of code was thinking they were 1 byte long, and the other piece of code, I think, thought it was 4 bytes long. So let's just pull up the pull requests, kind of like as we do. Oh, let me switch to the stream. we kind of start by just going through the diff of the stuff that I did. So we're going to look at closed PRs where the author is Tan Newt. Spoilers for the other stuff. So there's two things that I did. The first PR I did was just merged 22 hours ago. I was kind of on a tear yesterday, which is great because this stuff was really the fixes that I'm going to talk about here. I'm very glad that I've figured out because it was not fun at all to debug. Oh yeah, it's deep dive day. Hello, Summersoft. Alvaro asks, what GCC version is preferred for the CPX? For CircuitPython, we try to stay with the current version that has been released by ARM, which is, I don't even know. But then again, that's only true for the ARM builds. But generally, we try to stay up to date. So I have, for ARM, 9.2.1, and then I have for the IDF, this is whatever Espressive uses, so 8.2. There have been some reports of people trying 10.1, because I think Arch has it already because they built it themselves. And there's some bugs there that the MicroPython folks are looking into as well. So we're not on 10x yet, but for ARM we're using 9, and for Extensa we're using 8.2. So the first fix here, that was the issue causing us problems with validating the arguments, was that short enums was on by default. Now here I'm actually moving it. It was kind of extraneously in LD flags in all these make files that like are copies of each one. Hi, Simon. So you'll see that I delete it from LD flags and I add it to C flags for all of the different builds. In the case of the S2, we want to actually turn it off so that we match the IDF. So like both of them have it off. So we just delete it from the LED flags, which was throwing us off. I'm just going to skip that and that and that. So here it is for LightX, and I guess I will collapse these as well. And then IMX has the same change. NRF has the same change. SDM has the same change. This is why I want to redo the build system, is like factor all this stuff out. But this was the problem, is that the base C flags as defined in CircuitPython definitions.make had it on by default. So I had to delete it from there so that every port can choose to turn short enums on and off. All of them have it on except for the ESP32S2 because the IDF doesn't build with it. One of the other problems I fixed since I'm down here is it was weird that when we were getting that error code and it was doing a check and it was trying to output stuff, but we didn't actually see it happening in the debug console. And so what I figured out is that we were providing our internal printf that meant that the errors that the IDF was trying to spit out, the error messages, they were going to the USB CDC connection. They weren't going to the UART connection, which is what we were using for debugging. So I made that conditional here. And again, most ports have that enabled, but for collapse this for the ESP32S2, we actually want to disable the internal printf so that we can rely on the one that's set up by the IDF that uses the debug UART instead of USB. One thing I did is I did hit max stack size, so I just increased the stack size of the build from 3,500 bytes to 8K. That's still very small. Well, it's not super small. I think the SAMD21s only have like a 2K stack, but we could likely make this bigger. As folks who have been testing it out found, like the heap is pretty small too. So like there's a lot of refinement to making the stack bigger and the heap bigger that we can do kind of going forwards. If some of you who tried it found this bug where you may have seen me run into it on a stream as well, where I loaded up a file and it wasn't the correct contents. And it turned out this was the issue of basically when we're writing, I kind of hacked this together. So the thing is that the IDF only allows us to write in 4K blocks, which is super common for Flash. And so we have all this logic in external SPI or an external Flash that does all this caching, but it assumes it's external, whereas this is for internal. It's like externally managed, but by the library, so we treat it internally, which is kind of bizarre. And the IMX has this problem too, but we basically need a caching layer. And instead of factoring out the external flash cache, which is an issue I've opened on myself that I need to do, instead I just did like a basic version in this file previously. And I think I don't know if I did that on the stream or not, but basically there's a logic error here where it can tell us to write any number of blocks, and that number of blocks can happen. So blocks are 512 bytes, and that kind of sequence of blocks, that those consecutive blocks can start anywhere within the 4K sector. And so by doing this block offset, we start at the right place, but we weren't correctly stopping if the number of blocks that we were trying to write ended before the end of the sector, because this blocks per sector ends at the end of the sector. But we may not have provided, or we're not writing to the end of the sector. So we actually had to add this check here that breaks us out of this loop. So the way it works is if we're not the cached 4K block, we read the whole thing and then we copy over or write over the portion that we want to change. And then we erase and then we write it back. So that is why... this is why we were seeing some file system issues. It was like originally filed it as an issue of like, it doesn't work on Linux, but it does work on Mac. And I think that had to do with like file access patterns and like how it lined up. So this is the thing that has made the file system more reliable, which is great. So this change has a lot of really nice things. One of the other nice things here is ESP will actually raise an exception if you tell it to delay for 0 time. So this is just a quick way to switch out of that. I updated the IDF as well to whatever master was yesterday when I updated it. And one thing was that the USB initialization changed a little bit. So I cribbed some of this stuff from the change in the IDF so that we can actually set the drive strength and stuff. This without this stuff, it doesn't work. So it's definitely important. And then Ivan was looking at this when he was helping me out this week. Of course, thanks to Ivan. He pointed out that the priority for the USB task was probably a little bit high. He said it was like right near the priority of the tick, which is like all the timekeeping stuff, and we don't really want that. So I lowered it to 5, which is what his suggestion was. I don't actually know what the range is. So it seems to work, and we'll leave that. But all of the FreeRTOS stuff is a bit of a mystery to me. So that is a number of the small fixes. And then there was this one last issue. So I filled out all of the I2C stuff. I got scan working because of the short enum thing. So I could see that it could see the device. And I was trying to test the ability to actually read and write to the device. And I would constantly or weirdly get these... I would get Python exceptions that said bytecode not supported, which was very strange. And then I would also get like load prohibited errors from the ESP as well. And that was really frustrating. I was working on it like all of Wednesday and most of yesterday. And it's kind of in that class of bug that's like the most frustrating bugs you can have, because I found that if I figured it had to do with the GC. So the GC is the thing that manages kind of allocating and deallocating memory. And bugs like that can happen if you're deallocating memory you shouldn't have. And so what I found is that if I printed out when I allocated something in pi/gc.c, it would work. But if I didn't print it out, then it wouldn't. Then it would crash, which is like the worst kind of bug. Well, one of the worst kind of bugs. At least it was consistent. It would have been worse if it only did it occasionally. Um, and there's the thing that Ivan had been talking about, and I think we may have talked about it a little bit on the stream, is that the extensa architecture, and I had to tell myself this, is like, I'm so used to ARM that I feel like I kind of understand how the ARM CPU itself works. Whereas with the ESP32S2, it uses an extensa core, and that's a core, like a CPU I've never actually worked with. And I think we talked about it, or at least it came up where the extensa architecture, along with other architectures, does this really weird thing where like CPUs have registers to store state across instructions. And that's typically like 16 or 32 registers, depending on the instruction set architecture, the ISA. And the nice thing about registers is they're like the fastest form of memory. We've talked a little bit a few weeks ago about memory hierarchy. So basically, like the further away from the CPU you get, the like orders of magnitude slower the memory gets. So typically, when you're like calling functions, what you end up having to do is like write to the stack, which is in RAM, and RAM could be like 4 times or even more slower than the CPU itself. So it turns out that there's this thing that extensa does to kind of like hopefully not have to actually write to the stack when you're calling a function. And the way that it does that is that even though from the ISA side you can see 16 registers that you can deal with, when you call a function, you actually call it with a rotation. So extensa CPUs can have 32, I think it's just 32 or 64 actual registers. So basically, when you're executing code on there, it can only access 16, but it can also rotate which 16 within the 64 or 32 behind it that has access to, which I had never heard of this. But the idea is that you can lower the the execution cost of calling functions and returning functions if you're able to leave things in registers rather than having to write them out to RAM. And Ivan had pointed me to this before because we have this the way that the garbage collection works is like we basically say, okay, I'm about to free a bunch of stuff. Let me figure out everything that's already in use. And so there's a lot of different regions of memory that we look for things that look like pointers to stuff on the heap. And one of those regions is the stack. Because we may be like using an object and we haven't actually stored it anywhere else except we're like kind of like actively using it, even though we may be using it like 4 function calls up. So the way that works in CircuitPython, I don't need 2 tabs, is a port implements, oh, this is going to give it away because it has the, I'll show atmel. I won't show the fix. And please ask questions about this stuff if I could clarify some more. So actually it's not in here, it's in MP Halbert. But we have this. Oh, it's not there. Where is it? I don't think it's in here. SPN regs. Huh. Let's see. Unexpected Maker says you can give it away. There's two things that are pretty exciting about this. It doesn't matter. I'm looking for the function we call to get the registers. Anyway, we have this standard kind of function that we call that gets the where the stack pointer is. So you would look between the stack pointer, the active stack pointer for the function you're in, all the way up to the top of the stack. You basically look at everything that could be a pointer and include the stuff that is. But as I was saying, the ESP32S2 doesn't necessarily write out to the stack immediately when a function is called. So what can happen is you can have values that you've recently used and haven't stored anywhere else, but they aren't actually written to RAM. So the way that you can get around that is there's this notion of spilling registers or those spilling those values back to RAM. So basically, like, it's 64 registers and you're moving a window along. If you happen to get to like moving the window over some values that only live in registers, there's like an interrupt that happens that flushes those to RAM. So that you don't lose those values as you kind of like move the window over those values. And then if you are returning, you do the opposite. So like when you underflow, you get to the case where you need more values, you read them back from RAM. So the fix here is you can just like call, like if the window always shifts 4 and you have 64 registers. Oh, that's right. Summersoft points out the function I'm looking for is implemented in assembly. Yep. Yeah, so on ARM, let me copy this. That is right. Actually, what is happening here? We're talking about fixes to CircuitPython for the ESP32S2. Yeah, so this is the implementation for ARM, specifically this AMD51. So we have this function CPU get registers in the stack pointer. We get an array of 10 values, and we just push those the registers that are used by the ABI into our array, and we also return the stack pointer. That's super simple, but with Extensa, you can't actually access or you can't read those registers all the time. Thank you, Summersoft, for that. So what you have to do with Extensa is you actually have to force the CPU to write all of those to, you have to write those 64 or 32 registers that are invisible to some degree. You have to do something so that you force them to spill and write. Thanks, Anyet. Yeah, stick around, you'll learn something, maybe. So spilling the registers is the process that registers in that window or that ring kind of get written out to RAM. And there's this HAL function call that you can call for Extensa called window spill, and that basically forces it to write all those values out. And I had this big long comment because this is something I'd never heard of. And I sent it out for review yesterday. I didn't have any of these problems of like freeing memory that I shouldn't have. One trick that I should mention that I should have done sooner than I did is that if you suspect your memory, if you suspect that you're freeing something too early, there is an option in the GC file where you can say clear on sweep. And this will set everything to 0 when you free it, which is much nicer because if you don't set it to 0 when you immediately free it, it's kind of unknown when something else is going to write that memory and make it an invalid piece of data, because it might actually still be valid if you've just cleared it or if you've just swept it, but you haven't actually touched it at all. Anything using it may just be like, oh yeah, that's right. So turning on clear on sweep actually made me find the issue earlier, which is great. Or it failed earlier, which is really cool. So the last thing I want to talk about spilling registers, this is the last bug I fixed, and I fixed it like last night, and I was very happy. So Dan did the review. Um, Anyat Ahmed is there any C programming courses? Kind of need to learn them for my exams. I don't know of any specifically, but if anybody in the chat has links to C courses online, please post them up and I'll share them. So Dan did the review, and for those of you who don't know, Dan is awesome. He was at Berkeley in like the 1980s for his PhD. Yeah. I think he went to, I don't know. He's been in the industry for ages. He like carpooled with Eric Schmidt, who was like the CEO of Google for a while, when they both interned at Xerox PARC. And there's this great video on Dan's Halbert. danhalbert.org. There's this great video of okay, so his 1984 PhD thesis. There's a video of him that he made. Can you see that, or does it show up as a box? Programming by example. So this was a video that he did for his PhD thesis. Okay, so I won't. Yeah, I don't think you can hear it, so I won't keep playing it. But anyway, Dan's awesome. So he does this review for me last night about spilling register values because of the window. And read this review. Good catch. I'm pleased to tell you that I and Peter Kessler caused this problem for you about 40 years ago. And he takes a screenshot of this Google book search. He and this other person literally invented the idea of windowing registers. It says, this can be implemented conveniently as multiple overlapping windows superposed on a homogeneous block of registers. This approach was proposed by Halbert and Kessler and is used in the Berkeley RISC-1 and RISC-2 processors. So I don't know if you saw this blog post, but like Dan was in the class where they created the RISC-1 and RISC-2 processors. You'll all have heard probably of RISC-5, like it kind of is the start of that lineage. So Dan is amazing, and he invented, along with this other person, this idea of a window on registers. So if you like that, go ahead and give that a ta-da emoji. It's pull request 2974, and he merged it last night. So I know I saw, I like was eating dinner last night. I was like, what? Like he invented this? Like how cool is that? How lucky are we to have Dan working on CircuitPython? Okay, that's me geeking out about how awesome Dan is. Do we have any questions? I think that gets us caught up in terms of basically the fixes that we've done for ESP32S2 since last week. And it takes a little bit of time. Mark says, best code review ever. Awesome. Okay, so I think that brings us up to speed, which is right on schedule. We're like 33 minutes in. So we tend to take like the first 30 minutes to talk about what's been done. The cat has moved out of the sun and just onto the floor because it's too hot in this direct sun. So what I was seeing is I could scan for a device. I was using the SHT31D, which I actually don't have here under the overhead. I've swapped devices. Mario says, let's hang out here. Hello, everyone. Hi, Marius. Thanks for joining the stream. Okay, so I think I2C should be working, as we talked about last week. Hi, David. Welcome. Yes, Alvaro talks about Dan as well. Dan is the original author of the tool More as well. And he's told me that the name was controversial at the time because it was because it was pretty oh, YouTube chat disappeared. Oh yeah, because I switched to the overhead. If I switch back, the YouTube chat's there. Yeah, Dan told me that more was controversial because it was such a long program name. It's 4 characters instead of like 2 or 3. Ah, David Watts is 21 today. Happy birthday. According to Unexpected Maker. Okay, so I think I2C should be working. And let's start working on that. Ideally, we can get I2C working, and then either I could pull request it as is, or we could start on Spy. So what I did is let me switch to the big overhead. So my setup here right now is this is one of the Sala boards. Oh, that reminds me, I have one other thing I wanted to talk about before I get too into this. But this will be a good segue. So this is one of the Sala boards. I made this kind of like harness here just to be able to plug in to the breadboard. This is really, can I gripe a little bit? Doug says it's funny because less is also 4 characters. Yeah, it's true. I don't know how many years after more less came, but this, I have a second one. They're super wide. Why is that? Like if you put this on a breadboard, there's only 1 row left. Like they're just like almost not breadboard size anymore, which is kind of frustrating. David says he's not 21, he's 37. Mark says more is probably one of the first commands besides the basic cd and ls that I learned about. Awesome. And D Flowers is asking what IDE do you use to program the ESP32S2? I use Sublime Text to edit the C code, but I do not I did not program directly from the IDE. So like this is more of a text editor than it is like an integrated development environment. As you see, I'll just use the terminal to push code over. The other thing I wanted to show that I forgot about is Oshpark, my projects. Hopefully this doesn't show my address. And Permalink. I designed a board that adapts. Yeah, this is what Mark's talking about. I designed a board that adapts the. Actually, let's KiCad it up here. Adapts the Saula to a feather form factor. So if I open the PCB here in KiCad, you should be. Oh, you can't see my desktop. See in my overhead. There we go. Mark says, my baseboard PCB for Sala will arrive on Monday, hopefully. Yeah, I made one too. Except this one has a feather footprint. So if we 3D view it, hopefully my laptop's not going to fall over because the GPU is doing too much. I've had good luck with Oshpark's PCB quality. I've used them a lot. And I really like the After Dark style. They actually like got that idea from me. Yeah, Mark, you predicted my train of thought. So this is what the board looks like. It's got a spot for a micro B USB connector, which is the one that Adafruit uses and is available on its own in the store. And then it's got the Sala spots on the outside, and then it's got a feather footprint on the inside because that's the way it fits. I also put a quick connector and a JTAG connector. This is SWD, but it doesn't do SWD. It does JTAG. And I think I figured out the right pinout. And then I also put an LED here for D13. And if I just tilt it, you can see that the idea is that it would sandwich kind of onto the pins of the Sala and provide like so it could act like a feather. So mine is actually scheduled to come on Monday as well. So that'll be cool. Doug says, more was included in BSD 3.0 in 1978. From Wikipedia, Mark Noodleman initially wrote less during 1983 to 85, in the need of a version of more able to do backward scrolling of the displayed text. Interesting. All right, getting on here. Why is it so hot? This shirt must be hot. And I have socks on, but that's all right. Okay, so if you're interested in this, I haven't tested this board yet, so I can't promise anything, but it's only like $11 for 3 from Oshpark. If you want to order it, just let me know, and I'll give you the shared link. Just know that I make no promises that it works. I also pushed it to my Chickadee Tech GitHub, so basically all the PCB designs I do, I put on my company's thing. Mark asks, did you use my board as a base? Just wondering if I might be responsible for any measurement issues. I did not. I did not use Mark's design for it. I hope the dimensions are right. I did actually, like, one thing you can do is you can actually print them off, like print off the board outline. And I did it. I actually routed it backwards. I had the like 2 rows of pins for the Saula backwards. So I like routed it all and then like put it down and was like like the USB pins are on the wrong side. And so I had to like delete all the traces and reroute it after they were swapped, which is a lot of pain. Unexpected Maker Point kindly sent to Adafruit HQ some Feather S2s, but they're stuck in customs. So I will get those when I get them. And you did also, Alvaro says maybe both boards are on the same Oshpark panel. I don't think so, because I don't think Mark ordered from Oshpark. I think he did JLC or something. Marios points out the sun is a lot closer to Earth these days, especially to the northern hemisphere here. The sun is going down right around 9, I think. I didn't end up using Unexpected Maker. I didn't use your full pinout either, because some of them were just like right across the board. So I think I used the more important ones and then I swapped the others because the Pinmux is really nice. Anyway, if you're interested in trying that, I should be able to tell you next week whether it actually works. If you want to hold off, or you could just spend the $11 in case it does work. Or you can check my KiCad work and tell me it doesn't work. Okay. So let's talk I2C from that distraction. Yeah, Mark points out that he's in Sweden, so Oshpark isn't as quick. Yeah, Oshpark's in Portland, which is like 3 hours drive from here, so it tends to be pretty quick even with the free shipping, which is very nice. DigiKey also is really quick with the cheapest shipping too, even though they're further away in Minnesota. Okay, so let's do Meg. I've been moving all around. Change directories. And sorry, my video will probably hiccup here as I do an initial make. My poor laptop. Mario says, Mark, but that color though. Alexander says, can anybody help me with KiCad and macOS? Can't load the libraries and templates for design. If you hop in the Adafruit Discord server, which I should have plugged earlier, it's adafru.it/discord. There is a PCB design channel there, and I'm sure we could get you squared away. I use it on macOS, so I can help you. Not immediately on the stream, but later today or next week. Try not to work on the weekends, but that doesn't always work out well. I'm itching for some Age of Empires, though, let me tell you. I think that Mark says he wants pink PCBs. I think that I think Thea, who does the Winter Bloom Soul stuff, wants pink PCBs as well. The After Dark is just so nice. I love Osh Park After Dark. I don't know if I have some in the other room, but it's black fiberglass with clear solder mask, so you can see all the copper traces. It's awesome. I think for open source software, that is the way to go, or open source hardware, of course. JLC PCB with DHL takes 4 days to Sweden, and then Marius also points. Exostel says that, and then Marius Higher Out says same to Norway. It's 4 days for JLC PCB. Water's so good. Mark says Poston took like a month. Alvaro points out, sometimes I offload compiling with dist.cc. Yeah, I could do that. I have, like, this is all running on a MacBook Pro that's closed on my desk. I've got 720p video from the Hovercam. I've got the Salier, which is USB 3. I've got Type-C to the monitor. All sorts. Yeah. Let me go. I'll go grab an After Dark since you haven't seen this. I'll be right back. This actually works pretty well because I have the overhead. So if we do just the overhead, I've got this box of PCBs, and you can see these are my flip dip designs. So this is a normal Osh Park purple, and then this is a similar design but with clear solder mask, black FR4, so you can see the copper traces, and then you get the gold plating on the can get the gold plating on the pads. Lots of chat. Poston, not quite how you pronounce it. Lost. Poston. Seems like it's the same company. Bilar? Can anybody tell me what busio is? Busio is the API for talking to I2C SPI UART devices in CircuitPython. But yeah, this is what I love After Dark. The one problem with, there's a couple of problems with the After Dark service. One, not as many people get it, even though more people should get this than this. So it can take a little longer. Like you can't super speed it, so that it immediately goes to fab. And then the Game Boy. The other thing is that I have these Game Boy cart designs, which I don't know if you all have seen these, but they're the thinner. They're the 0.8 millimeter, and they only have that in regular Osh Park purple. They don't have it in After Dark yet. But I would love to switch to After Dark for all my board designs, because you can see the difference in color and you can see all the traces. The one problem is you can't see where the solder mask is, so you have to be a little wary of that. But okay, that's enough sidetracked. Well, who knows? I love to get sidetracked, so I can't say too much. Access Dell says, that's nice boards, thank you. They're for being able to sniff on dip chips. But that's enough of that. Enough. Alvaro asks, does anyone make biodegradable substrate PCBs? Something one could use for prototypes. Not that I know of. I think it's tricky because you have to have like a particular dielectric constant for like speed and stuff. I don't know that much about it. Okay, let's talk about what we have here. Let's talk more about the setup. So here we have a BME 680, and I snagged this because it is a chip that it's temperature, humidity, and pressure, but you can use it both with I2C and SPI. And so I thought this would be the best chip to use to be able to test both. I don't think we're going to get to SPI today, but if we did, I mean, that's what we'd use. Maybe we could do it quickly. But for now, let's just see if we can't do this with I2C. And what I have here is I just have this like quick wiring harness I did that takes power and then GPIO 0 through 4, I think it is. Yeah. Or 0 through 3, because there's 4 lines. 0 through 3, and it's kind of straight across. And then black is here because ground is on the other side. So this is our debug console for, I just did a clean and I rebuilt. Mark says, I see After Dark is clear solder mask. It's quite cool. We'll think about some project for that. Yeah. I need somebody, I'd love to see somebody get really creative with the 2 tones of copper and gold. And the copper shouldn't tarnish because it's got a coating on it. Okay, let's flip on, I guess you can't see this because it's off the screen, but right over here I've got a switch for the USB as I've used previous weeks. So I'll just flip that so that we can connect to it. We can see that the flash is being read as the OS mounts the device. And you can see here, you can't see here. Let's do this one. Here we can see that I've got CircuitPy and I've got a code.py here. So let's pop up what it's got on it. And it is actually doing a scan, but it's doing a scan on the wrong pins at this point. So let's figure out what those new pins are. In the overhead, green is going to be 0. So I'm just going to pull up the BME 680 page so I can see the layout without having to like move my head underneath a bunch of stuff. So it's BME 680. You can buy it for $22, $22.50. You can also click this buy on DigiKey button, which I was super excited they had that. Check the link. Marius, can you drop it? Go in Discord and give the link. I didn't see it show up in the YouTube chat. But I should be able to see it there. Okay, and then it looks like DigiKey has them in stock as well, which is cool. So all I wanted to do actually is just be able to see a bigger picture of this. VIN, we actually have a blank spot for the 3 volts out. And then we have ground, and then we have clock, data out, data in, and chip select. So clock is going to be GPIO 0. And then data, I'm not sure. So that's the thing is it's a data out and data in, but you can actually use it as I2C. So let's click into the Learn Guide to see how to do that. So the Learn Guide says Arduino wiring, and data goes to this second one. So data goes into data in, which would be 0, 1, 2. Da, 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 da. 2 here. And let's actually see if TO. It looks like it's working, but it hasn't printed anything off, which is weird. Something weird's happening. Let's see if we save. Does this do anything? This looks like it's okay. I don't know what this is doing. Oh, it's not control seeing either. How do I get out of it? Oh no. Me. Marius posted a link. Let me just pull it up. Oh. I'll show that right here. Just wanted to validate it's not something terrible. It's an isometric PCB design. That looks very cool. Cool. Those are neat. PCB design is fun, for sure. Nice work. Oh, am I logged in? Worked for me. Okay, here we go. Somehow it went again. Maybe TO is not super happy. But we found 77, and then we tried to use this SHT31D driver, but that's the wrong driver because we have the wrong thing. Mario says it's too bad they never added interrupts to the BME 680. Ooh. Unexpected Maker says the real thing looks amazing. Okay, so 77 is probably right. And in fact, we can see here that yes, the default address is 77. So let's just copy over. Tigerbite says it needs a Qbert on it. No problem. Nice design. Okay, so in repos here, I'm going to have to copy over the device. I've got drivers, and then the bundle, and then we're looking for BME 680. So these are basically, what we do is we zip up all of the drivers for CircuitPython for everything into a single file. And this is the source repo for it. So it's an easy way to just like clone everything and have a copy of all the different drivers. And let's actually, what we can also do is they also have examples. So we can look at the BME 680 simple test here. And in fact, we can just crib the whole thing like that. And that's actually what I did here. Plus debug prints for other stuff. So let's move time up here. I'm not going to import it like that. Black on black. Really cool. Okay. We have I squared C. And I'm really good at naming things, so I called it B. And debug false. That looks all good. Except I changed something, didn't I? Oh, yeah, I changed the busio import. If I save that, we find it. Hey! It doesn't look right. I'm pretty sure it's not 0 degrees Celsius here. And the altitude is nanometers. This is actually what I expected with the SHT31D. Sorry about the truck, if you can hear that. The SHT31D actually has a checksum, and what was happening there is the checksum was failing. So this is where it becomes useful or handy to have a Salier or other logic analyzer. And a logic analyzer is really nice to be able to just inspect what is happening on the bus itself. And we talked about buses last week, so I thought this would be a good kind of like sequel to that where we actually look at what it looks like. Yeah, it says gas is measured in ohms. I don't know, I just copied it. I didn't even know gas was a thing on this sensor. It is a it is a BME 680. Oh, nice. All four of them together. Okay, so let me go to the overhead as I wire this up. Just the overhead. So I have this thing here on my Salier. It's just a breakout where the black one is ground. So for those of you who haven't done logic analyzing before, as we talked about last week, black is your reference voltage or your reference wire. So you always want to make sure and plug that in. So, ooh, that camera's hot. And then yellow is the next one. And then I'm actually going to skip yellow. And I will just plug in, actually, maybe I'll just plug them all in consecutively. So basically, because the breadboard, the way breadboards work is on the outside, the plus row and the minus row is all connected. And then within here, these 5 spots, the 5 spots in each row are connected together. So by just pressing it in, I'm now connecting, this is connected to the BME 680 and the logic analyzer is connected as well. And then there's this gap, they're not connected across the gap. And then you have the same thing on the other side. So now we should be able to sniff what's happening on the bus itself. Hopefully something. We'll pull up the code too here. So we're going to do a digital capture on those 4 channels and just hit start and nothing's happening. Hit stop. This is a brand new interface. Oh, something is happening. Okay. I don't know. 2 seconds apart. Yeah, so like printing takes some time. So let's take a look. We don't expect yellow to do anything. We expect every other to do something. So 5 should be data and 7 should be clock. So let's actually turn 4 and 6 off for now. How do I hide the settings again? Probably just the button. And let's keep zooming in. Okay, so if you are looking at a logic analyzer thing like that, can you tell? Oh, you can't even see what I'm doing. There we go. Hopefully these lines are thick enough. I don't know if they are. Can you even see that? Yellow is connected to chip select, but we're not using it because we're using it in I2C mode right now. Mario says gas is measured in ohms because it's particles and they land on the hot plate and the current needed to burn it away is measured. Yep, I'm on it, Mark. You just haven't seen it yet. Thank you for the reminder that I should share my screen. Okay, so you can see it rise and fall. Thanks, Summersoft. Sweet. Okay, so if you're looking at traces, usually the most frequent thing that you're seeing is the clock line. So figuring out which one's which, the data line's going to kind of sporadically change, and the clock line's going to consistently change. And then what we should be able to do is, I haven't used the Logic 2 yet at all, actually. Make it just a smidge bigger. We can just click I2C, and data is the first one, and clock is the second one. So this is going to just verify to us that the I2C stuff makes sense. So this is a write and then a read. And it's right to the correct address. So it looks like the data line here is correct. And the 1D here is correct as well. Let's take a look at some other ones of these. So that is more interesting. This is a big long read. Huh. So the question is what is wrong? Yeah, great. Okay, so Mark can see it, Steven can see it, Exodustel can see it, Unexpected Maker can see it, and Mark says I switched to SIGROC. Yeah, I'd love to switch to SIGROC. I would love to have an open source hardware logic analyzer. And I do actually have a bit magic that I could use. I see some knacks as a clock stretching. It could be clock stretching. That's an interesting idea. So I think what I want to do is I want to print off what I think the driver's doing and receiving, and then we can compare that to here. Because one possibility is that we're not kind of like communicating with the IDF correctly. So let's edit our file. And the place that we can do that is in bus device. I think we actually do have a debug I2C device as well. I could also do it in, there's lots of places I could do it. Probe for device. So here, let's print out buffer and in buffer. Steven, I'm not using SPY. I should be using I2C. Marius asks, what is clock stretching? Ah, that's a great question. So I talked a little bit about this last week, but we can remind ourselves. The clock line is the line that is used typically to communicate when data can change and when data is valid. Yeah, I can share it. And clock stretching is a way for the device to tell the host that it's not actually ready yet. So basically, it's allowed to hold the clock line low to basically prevent the device from producing the clock. And that's what clock stretching is. So this actually doesn't look like it. It's possible. It's also possible that we're messing up the mode, which I think is what Steven's kind of getting at as well. That maybe it's acting like it's in SPY mode. Okay, Steven says, that's what I thought. It seems very lacking of 0x80 in the datasheet other than for SPY registers. Steven, if you could look in the datasheet and tell me what pin state of the other pins needs to be in order to be in I2C mode, that would be awesome. And we could do some spelunking into the datasheet as well. But first, Mark asked me to post this, so let me save the capture into, sure, session 1. All right, for those of you following along at home like Mark, I will post it in Discord. It's 11 kilobytes, so it's not very large. And let's pull up the datasheet too. I think what Steven's doing is a good idea. And if you want to find datasheets on Adafruit, the way to do it is you click the product, you get to the guide, which we're on here, and then it's usually under downloads is where the datasheet is. So you can also see the schematic. So one of the interesting things on the schematic side is that there's a logic shifter which means that it's doing the pull-ups for us, which is nice. And we can click the data sheet. I need to pull some pins. Hi, Mr. Certainly. I was reading the Learn Guide and it didn't say, it just left them disconnected, so it's possible that the pull is done in the breakout already for us. And I lost the downloads page. If we just look at the schematic. This is the beauty of open hardware. Can I tell you that? Not being able to look at the schematics is a pain. So the address line SDO is pulled up by a 10K resistor, and the chip select line is also pulled up. Chip select B must be connected to VDDIO to select I2C. I think that's what this is doing, right? Hi, Charles. That should be okay. Oh, let me show another trick. Can I do another trick? I only broke out so many lines. So the other trick that I could do, and yeah, I can do it, is a way to get the capture started when you want to kind of know is you can actually use another pin to trigger your capture. So you can't see the overhead. So what I'm going to do here is I'm actually going to yank the yellow wire, and I'm going to plug it into this other yellow that's a female, and I'm just going to plug it into GPIO 4. And what we can do is limit our script. Okay, we should be printing. So many things happening. We're not printing here. I'm so used to screen. It's just printing under the hood stuff. So let's save this and see if it starts up again. Oh, we're not printing. And then let's... There we go. We should be able to see that. Ah, now we can see what's happening. And let's not have it loop infinitely. Let's have it do just one. And let's also do an import digital IO. Let's have a trigger so that we can know when we care. D equals digital IO, digital in out. .io for direction. Digital IO direction output. D value equals false. I think it might be false when I do that. That's okay. And then D value equals true. So this will allow us to see exactly kind of the bounds of this transaction. Kind of like a chip select for SPI. So we go back to Salier. And we use the new one, which I don't really know. Annotations. Can we do triggers in it? Trigger, here we go. And we're gonna turn 4 back on. We're going to capture for a second after the trigger. We're going to trigger on channel 4's. This is what I was talking about last time, like edges. We're going to do it on a falling edge. And we're going to hit play. And it's looking for a trigger. We hit Control D. We do some transactional stuff. This is why I squared, well, one reason I squared C is slow. Okay, so this is all the stuff that we should see on our bus in our capture. So let's just confirm that. So this first thing is a write. Write 8, 9, 10. Huh. Oh, you see, I think we set it back to false. Or when we oh, we need to blip it. All our timing is off too, because that's a bug. So let's actually do d.value. It's true. Yeah, that's a problem. Actually, yeah, let's do it the reverse, because it's defaulting to false. And we'll change our trigger to the other side. Control D. Weird. Like a lot's going on before we set channel 4 high. That is really strange. Could be that it's in the wrong mode. Like this looks right. E0. That doesn't look right. Although that could be... Oh, we're doing a scan. This is all the scan. That's what this is. This is us scanning all the different I2C addresses. Let's turn that off, because that's generating a bunch of noise. Although I think we might trigger it indirectly with the driver. But let's do that. And start it again. Oops. Need the bus. There we go. Yeah, the driver's init does some stuff too. You're right. But Summersoft, we're printing in the bus device, so we should be able to see everything that the driver does. I think. Okay, so let's take a look. What's going on? So this is the check. This is the probe. Ah, true. E0B6. Oh, that's what I should do. Let's print trigger here, so that we know how it lines up. There we go. So, yeah, this is what we should see. This is a pain. I just like that Python prints ASCII by default with byte arrays. It's kind of annoying. Okay, so we do... Mark asks, what capture rate did you use? I don't know, the default. Is that... No. 6.25 megasamples per second. Okay, so the E0, according to Steven, is part of the reset, E0B6. And then, where's our log? So basically, I want to compare these. So the next thing we should see is a D0. Right. And so I2C automatically does the correct address. So there's our D0. And the next thing is a 61, which must be this A. It's a read plus a knack. That doesn't seem right. Is that because, you know, that this could be my code that's doing this wrong? Am I supposed to act this? Because let's pull up the implementation. Okay, let's ignore this. We're done with that. We can store this for later. And let's take a look at what I'm doing here. So that was on a read. So probe is definitely working. Write may not be working. But I think this is right. You start write by write. If you're supposed to transmit a stop, you do. And that's it. If you read, you do start, write, read, stop. But I don't know, do we do the stop bit or does the device do the stop bit? I don't know if this is correct. Let's just try it. How does, let's see if that works. Okay. And it's not gonna be, my USB is gonna be unhappy. I guess we don't actually need it open. So once it's loaded, this capture should get the first capture as it starts back up. And it should be in here somewhere. Yep. And let's see. Did this work any better? There's an ACK. Hey, look at that. Set up read and then, oh wait, it had a knack as well. This write has an ACK. So maybe I do need to produce the... I don't know. Do I need to set the stop bit? Is that right? That doesn't look any more correct then. All right, let's look at the docs. So there's this whole like command link stuff. And it's cool that you do the command link stuff. Yeah, Mark suggests maybe capture using another board could be good to check timings. It should be pretty timing resilient, and I know for a fact that like the delays and stuff in the ESP are gonna be slow. Like there hasn't been any performance optimization in the ESP yet, so I'm a little. I just don't want to show people how bad it is, because I don't want to do that today. Right by right. What does it say about acking and acking? Oh, it has an ACK value for the read command. are we setting that false when we shouldn't? Let's try that. Are we doing that wrong? No, we say we should ack it. Bruce also says I should do a known good. Y'all make too much sense. Okay. DCD in Discord says, after every 8 bits in one direction, an acknowledge bit is transmitted in the other direction. The transmitter and receiver switch roles for 1 bit, and the original receiver transmits a single ACK. If the transmitter sees a 1, instead it learns. Okay. Known good is always helpful. Okay. What do I have here? Feather M0 Express. I think I only have one BME 680, unfortunately. I think we do want to stop it there, and we do want to ACK. Oh, you know what? We might need a repeated start. I think we actually need that here. No. I'm thinking as if we had a write and then a read. Oh, ACK value is 0, and I'm giving it true. Oh, thank you. That's annoying. Numbers and booleans is just such a pain. Like, it should just tell me that it shouldn't be that. Ah, Steven, you're helping out anyway. I suspect, I'm hopeful that it's what, I don't think write byte. Actually, that's not what write byte takes. It's only in the reads. Bruce says, I only tuned in a few minutes ago, so not sure where we're trying to do. Hence my comments are nonsensical. Nah. Known good is always helpful is a good comment. It's one of those things where you're like, no, I can figure it out without it. And then the moment you do it, you like see something obvious and it gives you like that perspective. It's a good idea. All right, what file is that in? Let's use the macro. Really? It's just in the example? Wow. I could look at the example. Once again, so much logic. Sheesh, people. It's Friday afternoon. There's no room for logic here. Okay, so the 2 reads take ACK, and then look at this. Bool ACK enable. That's why I was thinking. All right, let's try it again. I just put zeros there. Yeah, this is where type systems are handy. You should be able to validate your code as making sense. Oh, I forgot to start the logic. So we can flip USB on and trigger it again. Disconnected. Connected. Cool. I'm excited about this. I just discovered this. A pro never uses examples. He does it live. No, I don't think that's true. I think a pro uses examples live. All right, we got the CircuitPy disk, and it is connected. Oh, do I need to control D? There we go. Look at that. No I2C device at 77. Well, that's worse. And we never got to our trigger, so it kept going. Why is that? The probe didn't even work. What did I didn't think I changed it. I changed read. And write is now the same. I wonder if I made it unhappy. Probe is the same. Okay, let's do this. Let's just unplug it. Let's try it one more time. Hey, there we go. Ooh. What happened? Why did we disconnect? Lose connection, unplug the sensor. I don't think I did either of those. Should be able to, yeah, this camera's still working. Let's trigger this again. And control D here. Whoa. What is it doing? What is this? What is that? Is it confused? Is it in a different state? All right, I think I will unplug the sensor. So I'm just gonna pull the 7 pin and just let it sit for a little bit. Counting in my head. And plug it back in. Okay. Let's try it again. What is that? I wonder if I'm generating noise over the USB or something. Wow, I actually made it worse. It shouldn't be a loose connection. It's so weird. I mean, that ACK flag is the only thing that's different, right? Let's just set it back and see if it works. I'm gonna turn the USB off. Just paranoid about hanging the USB bus. Debugging Fridays. But see, I figured this was something that like we hadn't shown on the stream yet. The debugging process. Oh, and I should. Is it too late? It's doing something. Oh, that looks promising. O2. The right has an ACK, but it was the reads that weren't being. Hi, Johnny. E1. Set up to read. Knack, 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 knack. Stop it. And that is what we're getting, I think. What is this? I don't get this. Is it? I don't know. How do you get out of key? How do you exit TO? I don't know. I don't really trust it. Why is it getting disconnected all the time? Control T plus Q. Control T Q. There we go. Let's try it with trusty old screen. Oh, well, it's not there because I turned it off. Thanks, Mark. You turn it on. This. Subtitles. The cloud is subtitling me on demand. What are we doing? We're debugging I2C. Not very successfully, but it's successfully taking the 2 hours of the stream. Unfortunately. Okay, so this, I mean, getting all these F's doesn't seem right. Does that seem right? Trigger. Right. Read. And then big long reads. And oh wow, did we? I'm not recording enough at the end of the. There's the first read. Okay, so we need to do more than a second because everything is slow after the trigger. Maria says debugging is nice. Debugging is important and it's a good skill. If everything's working all the time, it's like watching Usain Bolt running the 100-meter before you go for a run. Yeah, that has been a theme of the stream, hasn't it? Like me showing how much persistence and failure it takes to get anything done. So I think it's time for me to look at the data sheet. So there's our second read, our second and final read. Are you sure it's not 0 degrees Celsius? I'm pretty sure. It's like 77 today. So what's with this, huh? Set up to read. This is a repeated start bit. And it should have a write before it without a stop bit, right? This is a stop bit. Am I not mistaken? Or is this a... Maybe that's our problem. I don't need to gist the I2C bus IO file because I think it is actually what I have pushed. And all that 0xFF is just padding. Is that correct? I don't even know. Let's just turn off the stop bit. Or maybe I have it backwards. Or... So when can I get a proper beta with my translation? That's a good question. I could do that next week. We could do a release. It's still going to be a beta, though. We got to fix the performance issues on everything before we do it as a stable release. I slowed everything down. Mr. Certainly says, persistence and failure to get things done? That sounds like, well, life. Steven says 0x1d is measure status 0. Measurement status. Okay. I mean, this driver should work. Let's do in here. I know, those are like famous last words. In I2C device on the device. Let's also just see what... Oh, no. We're not doing a right and then a... Oh, no, there's stop there. Let's print stop out too. To know if we should actually have a stop. Huh. It says the stop is true. Yeah, beta is okay. I just want bragging rights. All right. Weird. Where is our data sheet? It's this newsletter one. Maybe it does need to be... Let's see. General electrical specification, sensor modes, sensor configuration, I2C interface. Let's look at that. 35. Digital interfaces. Single byte write, single multi-byte write, single byte read, multi-byte read. SDA and SCL are not pure open drain. It does not perform clock stretching. The SCL structure is high Z input without drain capability. The last bit is changeable by the SDO value. It cannot be left floating. If left floating, the I2C address will be undefined. Yeah, that would be bad. Okay. All modes, standard, fast, and high speed are supported. It really shouldn't matter the clock. So here's what I2C write looks like. Which is the slave address, register data, register address, data address. Not auto incremented. A read is... See, a read here does not have a stop bit. Right? This is actually a write, where you write the control register. There's no stop bit. And then you read the data bytes. Huh. Mark says replace line 221 in your code with that. Why is that? Can you explain, Mark? Like, we shouldn't have a stop bit here. That's one thing that's weird. I wonder... I could be using an old version of the driver. I don't think I am. But I could be. Okay, so here's the driver. It's got all these constants in these lookup tables. And then it's got subclasses for I squared C. Like this should be stop equals false. Does everybody just use this with SPY? Is that my problem? Doesn't look like it changed anything. Let's look at the logic analyzer again. We should now get correct stop bits on our writes. See? Right. D0, ACK. And then we have a read, a repeated start, and a read with a stop bit. That looks right. But why is our data not correct? "15 results. I know. That's why you test with a known board. Ah, so much logic in the room here. All right, hold on. Way too many logical people. Let me get some wires and reproduce this. All right, I'm gonna eject. Where is the 80 coming from after the read? I would assume the 80 is coming from the device. It shouldn't be coming from us. When I'm printing it out, I'm printing it out after the read is done, I think. Unless I'm not, which would be problematic. Oh, I turned it off already. No? I don't have a drive. It's unhappy with me. Okay, I need another USB micro cable. Here we go. I don't even know what's on this SAMD. If that's the data register, it's the SPY register. I don't think we're setting it. I think that's data we're getting back. What is measure status supposed to give us? Let's find the commands here. Measurement flow. I guess I should check to make sure I have a recent version of the driver too. But I think I've snagged it from the bundle not too long. Da, da, da. 20-bit. I expected like a list. Oh, look at that. Math. Data readout. Change the sensor. Yeah, I'm thinking that like maybe I should. Let me finish. Let's try this Metro M0 Express and just see if it works. I don't even know what version of CircuitPython it's got. But let's just see. 5.0 beta 2. That should work. It's got some sort of code in it. This is what... Oh, it's a UART test. Let's rename it. Ah. Oh. There we go. Sorry, you can't see this. I'm just renaming code.py to UART test. And then I'm gonna save this. And it's gonna complain that the drivers aren't there. So I will put a new window and do the drag the drivers over. Of course, I don't actually have it plugged in yet, so it's not gonna work. Let's not forget that. All right, BME 680. Oh, memory error. Of course I picked the smallest featherboard. Don't worry. I've got a Grand Central. It's the sensor with the biggest register ever. I was trying to rename. Okay, screw this. Sandy 21s, you're too small for me now. All right, this probably has CircuitPython on it too. Hopefully it works. Hey, it's doing something. 5.1, okay, that'll work. It's got lots of stuff on it. Rename. Ah, I did it again. I can like trigger the rename and find her without actually changing the keyboard focus. Okay, this is gonna complain to me if I do this. Module has no IO 0. What do I want to use? I guess I'll just use SCL and SDA. I think they're labeled. Oh, it's doing the I2C pull-up check. That's nice of it. Okay, I'm gonna pull. Can you see my overhead? You can't. So I'm gonna pull the connector from the ESP. And from here, I'm gonna do power from the 3.3 volts, which is 1, 2, 3, 4, 5. And I'm gonna make, I have a blue one here, so I'll make that ground. I'm gonna need one more. Oh, I'm gonna mix up all my colors. It's gonna be great. This is gonna be, which one's clock? First one's clock. Oh yeah. Can you tell I'm a software person? Clock. It's too far away. My wires are too short. Oh, breadboarding. So much fun. I can't wait to get my PCB. Okay, so it shouldn't complain about pull-ups now. It just complains that I have the wrong thing, which is fine. D13. I already have a copy of the driver on here, or did I move it over? this does. Hey, that looks right. Yeah, good job, Johnny. Got it back to 100%. We're going to keep adding strings, though. I can't promise you. As long as people want new functionality. All right, so it worked. Imagine that. So let's take a capture of it and compare the two. Can we do this? So we can leave this here, which I think is, this is the last capture we did on ESP. So let's take another capture on SAMD 20 or 51. That was so fast. That was way faster. Look at that. It ran in 45 milliseconds. Told you it would be faster. That's like way faster. Okay. So what do we got here? We got a write, a D0, and then a 61. Can I have two windows open? Does that work? I can't drag it away. Like, this took seconds. This is the probe, but we don't see... Did I miss it? Yeah, no. Oh yeah, here we go. So this is the probe, and then we have a E0B6. So the next thing we see here should be E0B6 ACK. It's a write. E0B6, okay. So far so good. And we can actually look at the speed. It's like just under 400 kilohertz, which should be just fine. And then let's, okay, so this is the first time that we do a write. So this is a export the capture as a CSV and then compare the texts. What's the rush? Why can't I just take my sweet time looking at this? So that looks right. Although this has the stop bit, which I just got rid of. And let's look here. Like, look at that. It got all sorts of different values. Like, but there's that 80. And here, it's a 60. Where is the table? What is this? Sorry, I don't actually know how to use this. I use the older version. Okay. Second. Terminal. Can I swap between the two? How does that work? E0B6, EED0, EF61, EE89. It looks the same. but one is much quicker than the other. Like, is it possible that the data just expires? Like, this is much quicker than... I'm actually kind of surprised at how slow it is. I mean, we are also connecting more. Like, I'm not connecting to CS at all right now. I wonder if it is that I'm connecting more than I should because the poles are wrong or something. Okay, this works. We confirmed the driver works. I am pulling all of the Grand Central wires away. Let's just drape the power over it. And actually, I'll pull it too. Make it unhappy. I should speed up because I'm running out of time. Okay, so I guess I could do it indirectly. So let me power it here this way. So I've got it flipped. I don't know how well you can see it. So I've got it flipped, so I actually have to use wires to connect the two. So I'll connect ground here. Breadboards can be flaky too, like that would be the worst. Ground there. Power is connected because I flipped it. I'm going to make purple be clock. When I say clock is 0. Data in is the one we care about. Which is one off. Okay. Let me switch back to this. We should be able to do this. Let's just restart it. And I guess we can do another session. Hide the analyzer. Play. Reload. And see if that works. Wouldn't that be it? That would be. Is it too annoying for you to send both the captures and send on Discord? Steven says, I think you have one missing stop bit. Yeah, I'll put him on Discord. This session 0 is different than the last one, right? You think that's why there's a stop bit too early? No, to send the stop bit, you have to send the stop bit yourself. Like the host always does the stop bit. Okay. So this is the bad one. This is the good one. All right, they're on Discord. Session 2, did we get data? Oh. Well, let's just look here. No, we're just getting all Fs. Read. And we get a bunch of Fs. Here, the stop bit is after the read byte. That's what I meant. It's showing it before. Wow, it's so much slower. Right. What's the analyzer look like this for this one? Yeah, it's like all Fs after that first. Which seems weird. Let me look at the code again. I wonder if we're not giving it the like duration or something. I squared C read. We write. We shift the address by 1. We put a 1 there to indicate that it's a read. We did the start bit. And then we read the data length. Then we stop. I don't think I can take a screenshot of the bad one and the good one and line them up because the timing is very different. I guess I could do it of the analyzer though. Or like Mark says, I think we could export it. Or can I export it from here? What's this do? Oh, it goes to it. This is the good one. This is the bad one. But this is missing the stop bits because in the byte view. I mean, I'm just a little, I think, let me turn the stop bit back on because I open a second copy of Logic 2. Yeah. This is so weird. No, this is not what I edited. It is the driver that I edited. This should make them equivalent. Except in timing. Just all Fs. This versus this. It's showing it before. I wonder. Let's look at the analog traces of this. it's possible that that's an issue. Like, we might be able to see all these F's be like somewhere in between. Okay, after the read EED0, you need a stop. After the read EED0. I have a stop. I turned it back on. You shouldn't actually need it. You shouldn't actually need to stop it after. But look at this. Well, this looks suspect. Like maybe it's just doing a bad job at capturing it, but that looks... Oh, that scale is all terrible. Let me change the scale. Oh, there we go. Like, that doesn't look right at all. Like, that looks really suspicious. Like, who wants to bet that if I... Let me swap this over. I gotta see this. Let's just make sure that the Salier can see it. But I think it can. So... Okay. This is data. My red wire. Actually, that should be enough. Where's my power? Okay. Let's do another session. That should have gotten it right. Oh, and of course I didn't do the analog stuff, but... So like this is it reading. I thought I still had the trigger on. Oh, but maybe the sessions are different. Oh, you know, I didn't connect the trigger. That's why. Doesn't that look suspect? Oh. That REPL output is not for. Oh, you know what? I put it on. That's so dumb. blinking the light that I used as trigger. Okay. So what we can see here, that's still pretty interesting. The Salier must not capture it that well. It is a little bit lower. Maybe it's averaging it a bunch, or... Okay, so we can't really, like, the clock, the data pin looks pretty strong. Let's compare. Okay, so the data pin looks okay too. It looks like it's just not captured that well. Yeah, so these are the bottom three are analog captures of the I2C lines from the Salier. So they could be, like, if I used a scope, they would probably be better captures. I don't know why they're so round. Like, this is the digital view of the world. But, like, this is just right around 1.5, which feels so bad. But this is also kind of like that, except it's a little lower, which maybe means that it just drains faster. I've got all these wires on here. This is running at 350 kilohertz. This is running at 400 kilohertz, and the average is higher. Increase the capture rate. Yeah, let's see what the settings are. Let's try it, but let's do it in the right session. There we go. Good idea. That looks kind of more like what... Yeah. There should be pull-ups on the breakout. In fact, I know there are because they're part of the logic level shifter. I know, I'm a software guy too. This is a reminder to everybody that digital is really just analog under the hood. Yeah, we could try to kick the capture rate all the way up. Since we're doing it. And it's been happy with me. Did we get it? I'm hitting the reset button. Yeah, we did. Ah, so this is more what I would expect. We were talking about this last time. This is the shape I would expect. Because to create the one, you're doing a pull up, so it's gonna have that like nice rounded pull. But then when you're bringing it back down low, you do it quite suddenly because you're able to drain really quickly. So this is the shape of signals I would expect, and you can see that with the clock line here as well. That it's, pulled up and then drops down and pulls up and drops down. Look at it chew through memory. Am I calling driver initialize anywhere? I thought I should be in make new. Okay, let's this looks like a good capture. Let's switch back. Let me connect everything back up and take a look at the ESPs. ESP with a higher capture rate. So clock is green and data is one over from that. I think that's right. So, and we have it pulled up. We're in session 2, so let's record over and hit Control D. Oh, that's Command D. Control D. And I, of course, unplugged the trigger. Thanks for hanging out with me, folks. I appreciate it. All right, let's take a look at this. So that looks okay. Master driver initialize. Did I really not call initialize? We just spent 2 hours not initializing? On line 140. Oh, I did install but not initialize? Oh yeah. So thanks for reminding me. Nina's streaming at 4. And I'm actually going to be on her show next week. So this is going to be a short stream next week. It's not going to go way over. I'm going to cut myself off at 90 minutes next week. Really? There's a separate initialize call? Does that like set the pins in a particular mode? Like... Configuration. Param config. Install the driver. Register free. Write buffer, read buffer. Data timing, timeout, data mode. You mean we get to sleep earlier next week? No, that's not what I'm saying. I'm saying... Yeah, Mark says, wait a moment, it's not a real method. Yeah, I don't see it. Oh. Yeah, I'm doing that. Oh, I'm enabling the pull-ups as well, which I don't need to do. Yeah, it's just calling param config, which I am calling. Maybe it just doesn't work. Did I finish my thought? You shouldn't go to sleep earlier. You should watch Nina's stream at 4. So like 20 minutes prior to now is 4 o'clock here. I know it's different settings, but... G is not working well. Yeah, but I don't need the pull-ups. I know that for sure. And it's so strange. Because like the first byte is right. Do I have to ack every byte back? Good night, Johnny. Thanks for stopping by before bed. I know it's late in Europe. I mean, the data we're reading looks correct. And I would love to get this going. Pull up disable, IO number, like those, that's definitely correct. The frequency's correct. I mean, probe is working. Write appears to be working. It's just read that isn't working. The length of the read looks okay. Let's check this. Oh, I guess we are. We are checking result. Good night, Marius. I'm sorry, folks. I'm running out of ideas, too. Hit buffering, refresh, commercial. What frequency are you sending in the constructor? I assume 400. We could try to slow it down, actually. It should work slower. Let's do that. 100,000. I just got like screen in my fingers now. It's just so strange. It might be like a BME 680 thing. And let's see. Let's do this again. Trigger should work. I'm now ignoring the frequency and setting it to 100, so we should be able to see. I hard-coded it to 100. There it goes by. It's doing more stuff. And it's done. Oh. Channel. The trigger channel is very noisy. So it is like bang on 100 kilohertz. Steven says, yeah, the only thing that had timing requirements was in the high speed mode. Rather maximum values. Yeah. I mean, in here we're knacking. Which doesn't seem right. We really should be acking these. Like these reads should be acked, right? Let's look here. Yeah, see, look. Read, ack, ack, ack. And here we're knacking. Knack, knack, knack. Which is... I just noticed in Twitch chat, Speed of Light Pen says, is the ESP a custom chip or is it based off another architecture? Summersoft points out it's based on the Extensa core. So why aren't we acking? Oh, is that this? Did we try that already? I think we did. We just like tried the wrong combination of things? I still think my earlier code needs adding. Yeah. Why? What does that do though, Mark? You want to knack the last value? Is that the deal? We need to knack the last value? What's this? Did you snag that out of the example? Did they do that in the example? Where are we getting any analyzer? This. Ugh, the window's just so small. Hide. It sent me there, but it didn't show me anything. Oh, because it's in the middle of this giant. Okay. Ah, he snagged it from the example. We need to knack the last one. All right, Mark, you're right. Let's try it. Looks like our reads never stop otherwise. Read master. ACK value is 0, NAC value is 1. Abominable says, every time he says NAC, I think of the liquid metal. Well, you're in a your ACKs and NACs are all what we're talking about today. So you're in the right place. Okay. ACKs and NACs. Be awesome to get this working. That looks promising. Looking at the examples for the win, it appears. Look at that. Oh, but there's such a gap there. Oh, Mark. How long ago did you first recommend that? I got almost a whole hour's worth of stream because I ignored that. Okay, great. Mark was right. Okay, let's turn it on and let's see that it works. And then let's wrap up. Print, print, print. Hey, yo. Looks like it's gotten slightly less warm in here. 34.3%. I will buy you a beverage, Mark, next time I meet you. Everybody give Mark a round of applause for reading the example that I failed to look at. Great. This looks like I2C reads and writes are working. So that means that I think I'll do a PR with just this. Actually, maybe I should do that now. Even though we don't have SPY and UART, we might as well get I2C tested over the weekend so that you all can try it. So let's just keep rolling here just for a little bit. It shouldn't take too long. Let's just clean it up. Although I think the prints that the print statements we're seeing. Okay, let's do the clock speed. Let's change the clock speed back because that wasn't actually the problem. We just had our NACs wrong. Actually, this is why I don't really want to do it because there's stuff to comment it out. Bruce says gold content. Okay, so I'm gonna delete this before I forget. And we could test it a second time or not. I'll just commit this, and those of you who want to try it can check my repo. I have a lot of commented out code of stuff that I wanted to do still, and so I'm gonna wait till next week to actually PR this. But fix I2C. Thanks to Mark. And I'll push that, and folks can try it. No, we don't need to force. Okay, well, this has been another deep dive with Scott. I'm Scott. I work for Adafruit. Adafruit's a company based out of New York. They do open hardware and open software. Check them out at adafruit.com. If you want to hang out with us all week long, you can check out our Discord server, which is adafru.it/discord, or somewhere on the screen here, there's a link to that as well. Discord GG/Adafruit, I think will work as well. We'd love to chat with you all week long. You can check out github.com/tannewt/circuitpython if you want to see all my in progress work, like the stuff that we just wrapped up here. This is a stream that I normally do at 2 p.m. Pacific on Friday afternoons. If I'm going to take Friday off, I'll shuffle it around and let you know. The way I let you know is I do a blog post on the Adafruit blog, which is blog.adafruit.com. And I also tweet it out on Twitter. My Twitter handle is TANNEWT, just like my GitHub. It's pretty much standard everywhere. I've had it since like the early 2000s slash like 1999. It was unique and it was like a random generator, but yeah. So you can find me on most stuff with that. You can find me here, like I said, at 2 p.m. Pacific. Next week's going to be a bit short because I'm going to be on Nina's stream at 4 p.m., which I'm actually going to swap over and catch the end of as well. So I recommend everybody check that out. She goes by NNJA on Twitch, and I'll ping me on Discord if you want a link. I'm happy to help you with that. Support Adafruit, adafruit.com. Check out Adafruit, or check out CircuitPython if you haven't. I'm surprised you got this far if you haven't seen CircuitPython yet, but I recommend it. And I'll see you next week. I don't think there's any other reason I wouldn't do next week, but keep an eye out for a blog post if that changes. And thanks again. I really appreciate y'all hanging out with me. Mark, sorry I didn't try that sooner. I should have tried that sooner. I just didn't understand that the knacks and the acts had to be different, as you could tell. And hopefully that also showed folks how logic analyzers are really helpful for understanding. And thank you for Skyscraper Jim, who's probably watching and just added me on Twitter as well. So thank you all. I hope you have a great weekend. Catch us on Discord. Check it out. Try CircuitPython on the ESP32S2. It should be much, much better than it was a week ago. So thank you all, and I'll talk with you next week.